hand the survey back to Noreen as you leave, and she will give you your certificate for the program.
Thanks. Like Richard said, I'm Ken Baudry, and I've been in this industry, seems like my whole life. I got out of college at a time when people were moving from timeshare mainframe IBM systems onto minis, things like Data General and DEC, Sperry, Univac, names you don't even hear in the industry anymore. And because I was the young kid right out of college, I got all the new projects. You figure it out. And so I've always worked in the industry. I've worked different aspects of the industry. I did engineering, electrical engineering for a while, during the heyday of the telecom build up when everybody was putting switches in. I was working a lot for Bridge Telecom, doing consulting. Eventually became a project manager, and now I'm a real estate broker. And if you add those years up, I'm not that old, so well, I am that old, but I don't have that many years in the business. I still do some of it all. And I think we have a 1750 kW generator going in either next weekend or weekend after next, right? On a project we're working on. So I do a little bit of everything. In trying to set an agenda for today, I didn't really know what to talk about. I could talk up here the whole week. And every one of these topics could be gone through in a lot of depth, but I'll keep it pretty high level. We can always talk on the phone again. If there's something that is really appealing, you know, Richard can always get me back. I'm going to start off talking about the Internet. And you might think that's, well, I'm not in the Internet business. It's not really that important to me. But so many of the standards, best practices, decisions, the way the industry is being built is all being driven by what's going on with the Internet. So I think it's pretty important to understand that what's happening there. If you understand that, it'll help make a lot of sense out of some of the standards and some of the white papers you see and what their applicability is. So then we'll go on into different types of data centers. Co-location, you may say, well, I'll never be a co-location customer. We own our data centers, but I think everybody has a little bit of a need for a co-location as a minimum. And I think everybody, sooner or later, you're going to get asked to deal with co-location. You're going to get asked, well, should we be considering that? And you'll need to know enough about it to ask the right questions and push the right buttons. Finally, talk a little bit about data center planning. There's some really easy, simplified methods to go about that. We'll talk about standards a bit, and then hopefully we'll have some time left for discussion. So what's the product of Internet? Is Internet there to help us send emails, help us to operate our companies more efficiently? No. Well, Scott, if you can't come on time, just come. The Internet is just like television. You know, television you're the product of television. TV producers produce movies, shows. They put that entertainment on TV. They package you up and sell you to the advertisers. So that's their product. Their product isn't really entertainment. It's you, the customer. So what's the product of the Internet? Same exact thing. The same exact thing. You're being sold to the advertisers. About 80% of our economy is consumer purchases. So that's what's driving the whole data center industry. It's driving design of facilities. It's driving production of hardware and software and applications. It's making a lot of things possible. Now, the Internet's a better medium than television because it's two ways. You get feedback, right? You can engage your customer and make them participate in the experience with you. And you can also push product over it. So it's an ad man stream. So TV, think about TV. There's TV broadcast, there's movie production facilities, TV broadcast facilities, and then TV once was propagated over the airwaves. Eventually it got onto telephone lines and then onto cable or broadband systems. Internet's the same way. It's peering points. Peering point is nothing more than a big switch. but all the traffic goes through peering points. And that's, if you think of a peering point, it's kind of like an airport. You can take a train to downtown Atlanta, you take a bus or cab from the train station to the airport, you can get on a plane, you can fly to Chicago, you can get into a cab in Chicago and go to your place, right? So it's just a network of transportation, and that's what the internet does for you. So the internet was developed around telco. In telco, there were major carrier hotels and switch centers where most of the traffic either originated or terminated or passed through. And so IP peering points built up in these same locations. There's 4 locations: San Francisco, Los Angeles, New York, New Jersey, and Northern Virginia, that carry the bulk of the internet traffic today. There's other cities, Atlanta one of them, that are also major peering points, and those 9 to 12 cities, depending on whose list, are the key peering points in the U.S. So when you send an email from your server, it eventually makes it through a network, most likely at 56 Marietta. And if you're going out to somebody in California, maybe it goes through one Wilshire or 365 Main, and it pops out at the other end through a host of circuits and networks. So if you look at those key cities, I don't know if you can see the green triangles, the blue and red dots. I believe the red dots are Colo hotels, and the blue dots are peering points, or vice versa, and the green triangles are Collocation Facilities. These are major facilities. They tend to be high-density facilities, and they tend to be about pushing product to the internet. So if you think of these peering points like a funnel, like an hourglass, and you got that knot in the middle, and the base of the hourglass is consumers, and the top of the hourglass is producers, and they're trying to push product out of the internet, out through the internet, through that knot in the hourglass, which are these 12 cities, to consumers. So where do you want to be if you have content to deliver? You want to be next to the peering point. If you look at where these peering points are, this is a map of county population. They're all in very populous areas. And this is population density, but basically just shows the same picture. All about the consumer, right? That's where the consumer is. That's where you want to be. And then there's several peering points that take you to the rest of the world, 4 in particular for the United States. And there's an awful lot of traffic going out of the United States. Everybody, for as much controversy there is in the news about whether people love Americans or hate Americans, everybody loves American entertainment. It's being pushed out over the internet big time across the whole world. And recently you've seen the events in Egypt and Libya, and what's the first thing they do? They unplug the internet. So why do you want to be in those major peering points? From a technical standpoint, performance. Your circuit distance is shorter, so you have less latency. You don't have to go through hops. You have less risk of backhoe fade. If you only have to run a few blocks with a piece of fiber, it's a much smaller chance than if you're running miles that'll get dug up. So it's reliability advantage. Business advantage is low cost, especially if you can be in the same building with the peering point. Then you're just running a piece of fiber, you pay for once and you're basically done, as opposed to buying bandwidth across the network. Disadvantage, competition for resources. Northern Virginia is probably the hottest market there is right now for data centers, and it's all occurring in an area that's about 5 miles by 5 miles. Basically every industrial building, even flex buildings that come on the market, get swooped up pretty quickly to become internet data centers. The power company's having to build additional substations to bring in that much power, but it's this whole idea of being in a collection together, side by side, close connectivity at the airport as opposed to across the town from the airport. So this brings up the first kind of data center, internet co-location. Generally pretty large facilities sitting right on the internet, right on the peering points. And so if you wonder why there's so much business in Northern Virginia, that's why. That peering point carries a lot of traffic. Santa Clara is probably the largest peering point in the United States. You don't see quite the same activity out there because of competition for resources. There's not as much land, and you can't get power. So in theory, Atlanta could become a major peering point, could grow in size because of availability of land and availability of fiber. These companies down here at the end are all in what's called Content Delivery Network, or CDNs. And so their job is to push product, content over the internet on behalf of other people. So somebody else builds the content. They what do you call it? Not spool it out, but stream it out, right? So when you buy software, Limelight's one. You buy software, a lot of times you're buying it through Limelight. They're pushing those large packages out to you. Generally, you want to be in the same building is your best bet. If not in the same building, across the street. If not across the street, you want to be in a position to run your own dark fiber between the buildings. But there's Colo centers all over the country. This is a map from a website called datacentermap.com. It's a volunteer service where you can go in there and put your address of your facility in there. You do it for marketing reasons, right? Completely volunteer. There's about 1,000 sites in there, and this is how they disperse across the country. And if you look at the low inset density map, you see that they basically fall in major population areas. And why is that? You have to have customers. There's no customers in a town with no people, no business. Most of these data centers you see in these small towns are relatively small, maybe 10, 20,000 square feet. And that's probably only needs 1 or 2 Colo facilities in that town to support all the business they're going to get. So the second type of data center is what I call general colocation. And these are my definitions. There's no industry standards definitions in this industry. So I call general colocation is just traditionally location-based colocation. Where do you put it? You put it in your own hometown, or you put it in the adjacent town, close enough to be practical and inexpensive, and easy to get to and manage. And I think a lot of big companies looking and saying, well, you can build forever in these big cities in Northern Virginia and keep packing it in, and you're just going to attract that business, but you're not going to attract it indefinitely. It's just a little far-fetched to think that I want to have my servers, an airplane ride away. And in the real estate side, people call you a server hugger if you want your server close to home. But it just doesn't make sense. Enterprise data centers. I'm going to break this down into 2 types. Enterprise data center is just what it is. It's a data center used by a customer for his own business. It could be leased. It could be owned. It could be freestanding. Could be in a multiple tenant building. It could be space leased from a colocation center. Here's some of the. There really is no good list of data centers across the country. Why? Who really wants to publish where their data center is? In general, it's pretty easy to figure out. If you want to figure out, just get on Google and look for a lot of cooling towers and generators. If you see an office or industrial building with 3 generators, 6 generators in the back, they're either growing pot or they're a data center. Both take a lot of cooling. I've heard that at least. So then there's smaller enterprise data centers, and I usually put these at 5 or medium 5 to 50,000 square feet, and there's no real guidelines for these. But they're data centers that fit in office buildings generally, or industrial buildings. So you build them in the basement of the building, you build them in the hospital. Unfortunately, many hospitals I've been in, their data centers right next to the boiler room because it was undesirable space 15, 20 years ago. And IT was an overhead. Now IT is core to patient care, And people are waking up going, wait a second, my data center is right next to the boiler room. Really shouldn't be there. So we see a lot of activity in the hospital industry on looking at how they're going to resolve their data center problems and upgrades. Large enterprise data centers. You've probably seen a lot of announcements in North Carolina, and this is just a few of them. Why North Carolina? There's nothing there. North Carolina was largely textile industry, tobacco industry, and it all went away overnight. And Duke Power got left with tremendous amount of generation resources and distribution, and nobody to sell it to. So they got very aggressive about marketing cheap power. So how cheap is cheap? 4 to 4.5 cents a kWh is what you can buy it for in North Carolina at these big data centers. You're probably at 6.5, 7 cents here. Is that fair? When you're running a building at 10 watts a square foot and you're running it 5 days a week for 40 hours a week, it's one sum of money. When you're running it at 150 or 200 watts a square foot, 7 days a week, 24 hours a day, it's about 20 times as much money. So suddenly cost of power is one of the key determinants on where you locate your data center, especially if you're really large. You get smaller, it becomes relative, right? So if you're buying one rack in a colocation center, what do you really care? Difference of $100 over the course of the year, it's not worth your time to figure it out. You got 100,000 racks at a couple $100 a year difference for every rack. It's worth taking a look at. So the large data centers are largely driven in the location by property taxes, sales tax, and power expenses. And really, you wonder, typically politicians want to attract businesses that have people. So why would they want to attract a business that didn't bring any jobs, right? Politicians want votes. It's free money. Most communities charge franchise tax for their power, right? So if you got a 10% franchise tax that you get for all this huge amount of power that's going to be consumed, and at the same time you don't have to build any new hospitals, no new schools, no new courthouses, no new police, no libraries, no health care or public health centers. There's no liability for that income. It's just income. Because everything a data center consumes is bought from another business. It's bought from the water company. It's bought from the utility company. It's land. You don't need new roads. So it's a great deal for a politician to bring in free tax revenues. So kind of in summary, these are my 4 types. Internet colocation, generally around the peering points. General colocation, which can be anywhere. Small, medium, large enterprise data centers, and then the mega data centers. Now, the reason I wanted to talk about data centers in these 4 types, because they vary greatly in what's required for them. What you see is white papers that say you have to have 200 watts a square foot, and you must do containment. And if you don't do this, then you're not a real data center. That's about as big as a bunch of crap I've ever heard in my life. Requirements differ. Most data centers, most enterprise customers are not even 100 watts a square foot today. Most enterprise customers probably will get over 100 watts a square foot. When you start looking at the internet colocation, that's all about bang for the buck. It's a commodity product. You got to push it out there. You got to stack those servers in, and those data centers really can be 200 watts a square foot. When you look at an enterprise data center, how do you stack and rack cabinets? Bill's responsible for Windows platform, so we think Bill's going to grow from 2 cabinets to 5 cabinets. Let's assign him 5 cabinets. Sally's got Unix. Let's assign her 4 cabinets. At the end of the day, you've got 20 different platform owners in the data center, and they each have an assortment of racks, each partially full, and the data center's full. You can't do that in Colo. And you can't do that in Colo because you pay for it differently. And if you pay for it and if you build it that way, you'll find it so expensive that you can't afford it. Doesn't mean Colo isn't cost effective. If you think about it, most Colo centers are basing their rates around 150 watts a square foot. And on average spacing, we talk about a 16-foot pitch where you've got 4-foot hot and cold aisles and allow for a 4-foot deep rack. On that space, and 150 watts a square foot is about 5 kW a cabinet. Most enterprises are only running 2 to 3. If you buy cabinets at 5 kW each and your product set is only 2 to 3 kW architecture, say, you have to buy 2 or 3 times as much rack space as you need to fit your equipment in there. So the way you make co-location work for you is you rack it in really dense. That's the way it was built. That's the way the design was made. And if you build your network, your computing architecture that way, it works. It's very cost effective. Most people can't figure that out. Why? Because most people have a real estate department, a facilities department, and an IT department. And an IT department says, I'm going to do business the way I do business. I'm not changing the way I operate because I'm moving to another facility. And maybe real estate saying, well, we don't want to put up $50 million to build a new data center. We want to lease, right? So you really, to be most effective, you got to come together as a team and look at all the numbers, and that's multiple line items. It's not just a real estate line item. It's not just an IT line item. It's both of those, and it's operations. And it's pretty complicated to do. But the technical requirements, be careful whether you're expanding your data center or building a new one or moving, that you really focus on technical requirements that meet your need, right? Because data centers are pretty expensive no matter how you go about it. And if you're not meeting your requirement, then you're really spending a lot of extra money. Okay, on top of the co-location industry, there's all kind of services available. Managed services, you hear about cloud computing. And when you start looking at co-location, you have these options available. So when you start looking at a real estate deal or at construction, comparing the two, you've got to also compare, well, how do I run the facility? What services come in the contract? What might be better doing outsourcing? Most co-location facilities, as a minimum, have what they kind of refer to as hands and feet. So what are hands and feet? Middle of the night, you got an alarm on your server. You call the center, and they send a guy from their NOC over to your rack, and they reboot the server for you. That's hands and feet. Relatively simple things. Mounting a tape to do backup. Then they get into more sophisticated services like managing the firewall, managing bandwidth, managing the operating system. And you start thinking, well, as a data center operator, can I do this more cost-effective or less cost-effective using my own people? So the exercise becomes a much bigger exercise than just simply comparing construction to lease rate. And the way you do it, you have to bring it all back to a common denominator. And I like to use net present value because, there's upfront costs, there's, lease or loan amortization cost, energy cost over time. If you bring it all forward to net present value, then it's pretty easy to compare apples and oranges and bring them all back to apples or to fruit. Okay, co-location. It's a new industry. It didn't exist 10 years ago. It kind of started, I guess, around 2000, maybe 1998, 2000-ish. A lot of companies went out and built these huge centers. Most of those companies went bankrupt. The market wasn't ready to buy what they had to sell. There were a lot of questions, legal questions. What happens if the co-location center goes bankrupt? Who owns my software? Who owns my data? was probably the bigger question. There were some big failures. Their shoe company, and I want to say it was Reeboks, but I don't really know, had a data center where they leased space from that failed, and their website went off the air. So there were a lot of questions about, security of information, right to self-cure if there were issues and problems. By and large, most of that's been worked out. I think most people feel pretty comfortable today with Colo. Probably, depending on who you ask, 15 to 20 to maybe as much as 25% of all data center space today in the United States is some sort of Colo. At the same time, the market's very immature. You go to one Colo operator, oh, it's Tier 3 space, 200 watts a foot. Just pay me this money and it's yours. You look at the facility and just like you buy your generator and you got a 2,000 kW generator, is it 2,000 or is it 80% of 2,000, right? You don't run it full blast. So what are they talking about when they say it's 200 watts a square foot? Is it 160 or is it 200? Is it watts or is it volt amps? I won't say it's purposely done, but there is just a lot of issues, and people talk about it differently. And you really got to be careful to make sure you understand what the numbers mean if you buy colocation of any kind. Committed capacity, is it usable or is it rated? Renewal rates. For a while, it's about a year and a half ago, after the dot-com boom and bust, a lot of these facilities became available at 15, 20 cents on the dollar. So they were bought, they became colocation facilities, and people started leasing out rack space. Not a great demand, so it was relatively cheap. Over time, the market's improved. There's a market for the product now, and the rates went up. So you see people, writing on blogs, and you get calls, and my landlord doesn't like me. Why doesn't he like you? Well, he's raising the rent from $40 a square foot a year to $40 a square foot a month. He wants me out of here. No, he doesn't want you out of there. He just finally can sell his product for what it's worth, right? So, but it's always caused us hard feelings when rates go way up, especially if you haven't been forewarned. And equitable renewal rates remain a challenge. If you go in there and negotiate a 5-year deal, and then you've got, your 5 years are up, what are you going to do? You're going to move? At what expense? So it's $10 million to move. Can you afford to move? You're in there for good, at whatever rate the landlord wants you in there. So when you start looking at negotiating, whether it's one rack or several racks or wholesale space, 10, 20,000 square foot suites, you really need to be careful about how you buy it and buying it right. So we touched a little bit on services. The industry is kind of segmented with different players playing their own role. So there's companies that specialize really in just the basic shelf or rack space, white space, floor, PDUs, UPS, air conditioning. You lease it, you go in there and do whatever you want in there, right? So it's kind of like doing it yourself with other people's money. Some of those companies will staff those facilities to a certain degree with personnel that will manage the generators and utilities, manage your maintenance programs, provide security, pay the taxes, keep the lights running, basic real estate type stuff. And then above that, you start getting into services. So what are services? Manage the bandwidth, managing servers, backup and storage, these kind of things. For a retail colo provider that gets $1,000 a rack for a month, right, just for the basic rent and power for that rack, he might be able to get another $6,000 or $7,000 in services for that rack. So the important thing is that you buy from somebody that wants to sell you what you want to buy. So when you look at some of the companies in the marketplace, Equinix. Equinix will sell you wholesale colo. They're at 180 Peachtree. It's going to be 2 to 3 times as expensive as anybody else. Why? They want to sell you cross-connects and services. And if you just want to buy real estate from them, they're still going to make their profit. So instead of $1,000 a rack, they're going to be at $3,000 a rack, because on that $6,000 of services they're not going to sell you that you don't want to buy, they're still going to make their $2,000 profit. And if you'll pay them for it, great. I'd sell you that deal too. So it's important that you look, and there's nothing wrong with Equinix. It's just, the point is, it's important that you look to buy from somebody that sells what you want to buy. So if you want to run your entire operation yourself, you're basically looking for a real estate deal where they design, build the space, you operate and use it. So make sure you start out with the right kind of service provider. Some examples in the marketplace. HP and IBM, what they really want to do is have you outsource your whole IT department to you. QTS, Digital Realty Trust, or Digital Realty Trust is more the pure real estate model. QTS is kind of a hybrid somewhere between a pure real estate model and services. Telex, which is 56 Marietta, and Equinix, Terramark, they're more about connecting to the internet. And then most of the telecommunications companies offer some kind of co-location service. They're really after selling you bandwidth. And if you think back to the early days of the internet and co-location, most of those companies that built those big centers were related to a carrier. They're either the carrier or a subsidiary, or had substantial investment by the carrier. And when you call them for pricing, it was kind of, how much bandwidth are you going to buy? And you tell them how much bandwidth you buy, and that'll determine how much your real estate cost is. And so we moved from there, after those businesses failed, to what was called carrier neutral, where there's already multiple carriers in the building and you can get your own carriers. But it's interesting that I think it was Verizon bought Terramark facility in Miami. And you have to wonder if the market isn't going back in the other direction of carriers trying to sell real estate inexpensively so that they can aggregate traffic onto their circuits and sell bandwidth. So that's just more of being aware of what your service provider really is trying to sell you, where they make their money. So from a facility option standpoint, for an enterprise customer, you really have 3 options. You can own, you can lease, or you can subscribe. We really didn't talk much about subscribe, but that's infrastructure as a service, also known as cloud computing. So the vendor puts in the server, the software, the operating system, manages it all, and you pay so much a seat, or so much an hour, or some kind of subscription-based usage. The good thing about that, you don't have to put up any of the money up front. You just pay for it as you go. At the opposite end of the spectrum, owning, you got to put up all the money yourself. And not only do you have to put up all the money yourself, but if you say that's a 10-year horizon and that you're going to grow 7% a year, you got to double the size of your data center day one. And then if you don't ever grow into it, now you've got capital deployed that you never use. It's twice as expensive as you thought it would be. So there's a lot of things to consider. There's no one way really that's best. Just a lot of consideration. You got a lot of homework to do. All right, shift gears a little bit. Data center planning. I started out as an engineer doing electrical work, and I was like all the other electrical engineers when we did a data center. Well, tell me how big a UPS you want, and I'll draw it. And probably 90% of all engineers are still like that today. Tell me what you want, and I'll draw it. Or do you need 2 UPSs or 1? Well, if I'm the expert, my job is to bring advice to the table and help you make good decisions. You know, and I've done enough data centers that I've kind of developed a planning approach. It doesn't work for everybody, but it's a pretty simple planning approach. Oops. I'm glad I went that way. All right. It's a pretty simple planning approach. It looks at a data center like a parking garage. When you think about a parking garage, it's just a big empty building with parking spots all the same size. You don't really care as the owner of that parking garage whether somebody parks a Toyota, a Honda, a Chevrolet, a Ford, red car, blue car, green car, convertible, pickup truck. You just don't care. Why do we care what goes in the spaces in our data center where we put cabinets? Yet most time when you get involved in a data center project, it drags on forever. Well, give me a list of all the equipment you have. Duh, for what? Right? Tell me how big your UPS is today. I'll know how to size it. That's really missing the boat. That's just saying you're replacing a data center. That isn't saying it's positioning you for the future. Okay? So there's a couple things you got to do. You really need to look at what are your business requirements. What is your computing model? Okay? Are you going to virtualization? Well, we usually start off projects and IT says, oh, well, yeah, we know all about virtualization. We're already virtualized a certain amount. And most companies are only about 10% virtualized. A lot of companies still say, we'll never use virtualization. I don't like that technology. We're not going to do it. In the long run, it probably really doesn't matter. You're going to be forced to use it. You're going to be forced to use it because that's the direction the market's going to take you. That's the direction of the manufacturers of equipment, the writers of applications and operating systems. They're all marching in that direction. And if they're marching that direction, it's invariable that you have to march in that direction. Okay? So when you start looking at, you know, what is your computing model, gives you a framework of just how big is my data center going to need to be. When you start looking at, you know, reliability, what can I really afford? If you sell websites, host websites, $10 a month, you put 500 on a server and you advertise on the internet, right? And you can go out on the internet, just put website hosting on there and you'll come up with thousands of hits. Real low-end product, real cost competitive. Can you afford the best data center? Not if you want to make money. So if you want a website that's got fully backed up with redundant systems, Tier 3 or Tier 4, whatever standard you want to build to, you're probably going to pay $150 a month for that website versus $150 a year. But the guy that does that low-end hosting can't afford it. So it's pretty important to figure out what your business can afford. And I know IT always says, well, we can afford everything. We've got a free hand. We can write a check for whatever we want. I've got signature authority. But at the end of the day, data centers are expensive. And if you haven't done your homework, then what happens is the CFO says, do we really have to spend all this money? So now you've spent 6 months, 8 months trying to figure out what you want to do, and the CFO shoots you down with one little question. Do we really have to spend all this money? And you're back to the drawing board. So, you know, kind of the process I like to take people through is, you know, what is your computing model going to look like? What can you really afford? Try to get buy-in from management at some level, whether it's the CFO, somebody on the board, a president, somebody that can talk with the other key decision makers and help them understand what's coming down the road. So when you walk in there 3 months later and say, oh, we got this $20 million project we want approved, they already know that you're tooling around with the idea of a $20 million project. And then there's the planning approach of how do you get to square foot and power. So, you know, kind of the process is identify the need, gather requirements, create a budget and schedule. It's high level, but people have to start being prepared for spending money. Obtain a preliminary funding commitment. yeah, you're authorized to go down this route, and we think we can afford this, and we think we can build it. Do some high-level design, confirm the budget and schedule with the contractor, acquire the real estate, and then go into the final design, bid or negotiate it, build, commission, move, and operate. And of course, that's the more complicated project because you're all doing it yourself. But essentially, at the acquire real estate point, if you had acquired it from a wholesale data center provider, they would basically do the rest of that all the way to the move point. And you just come and move in when it was ready. So we talked a little bit about, the parking garage concept. How many spaces do you want? And what do I do about those big pickup trucks? The kind that John Banco drives with 4 tires on the back and, can't quite get under the bar in the garage. What do I do for electric vehicles? Right? I got to provide chargers. Well, the truth is about 90% of a data center, 9% of a parking garage is all the same. Then you got a loading dock, you got some spots on the side for the big trucks, you got a half dozen spaces for handicapped and a half dozen spaces for electric cars. So you design it all the same, and then you handle that 10% as exceptions to the rule.